Number 16, we need to find the indicated value. We need to find the perimeter here. Perimeter is when you add up all the sides. We know that the bottom here is 8 centimeters, so that means the top is also 8 centimeters. And they tell us, or we need to find out what these two sides are. They do give us the area. Area equals base times height. They say that 40 is the area, and that is the base is 8 times the height. So what is the height of this shape using this equation? 8 times what is 40? That'll tell you what these question marks are. Then you can find the perimeter where you add all the sides. Number 17. If possible, we need to draw our answer. If it's not possible, we need to explain. Is a triangle with sides measuring 4 centimeters, 6 centimeters, and 2 centimeters unique? So let me draw, here's a 6 centimeter line. And now we're going to make a triangle that has other sides that are 4 and 2. So let's think about this. If I make this is going to be, here's about 4 centimeters, and here's another side that's 2 centimeters. I've drawn it, but there's a problem here. This isn't a triangle. We've got an open space here. And the reason I have an open space, and I can't just say, oh, I'm going to get a little more, and I'm going to add a little more to this and make it a triangle. I can't do that because my sides aren't long enough. And let me show you why. Let's imagine that this side, we moved it to here. So there's our 2 centimeters. We're going to move it to the left and put it like straight up and down. And this 4 centimeter one, we're going to move over. This is our 4 centimeter. So think about that. We've got a line that's 4 centimeters and a line that's 2 centimeters. And we're going to try and make a triangle out of that. So if this is 4 and this is 2, this can't be 6 because it's going to have to be less than 6. And here's the proof. The proof is right here. They wouldn't touch. They're not going to reach. They're not going to touch until they're the exact same line segment as our 6 centimeters. So this is not possible because our 2 shorter sides don't add up to more than 6 centimeters. Number 18, we need to know, is this a valid sample? Is this a fair question? Did they, let's see, did they ask the right people? Is the sample valid? The teachers wanted to see if students would attend after-school math tutoring. They surveyed 20 students who had stayed after school for language arts tutoring. So we need to know, did they ask a biased question? Did they ask the right, did they ask a fair question? Did they ask a fair amount of people is what I mean. So like they only picked people who have stayed after school for language arts tutoring. So do you think that those people would say yes or no in a fair way that represents the entire school? Or should they ask other students too? So you need to decide, is that a fair group of kids? Because like if I'm going to start a tutoring club, should I only ask students who are doing good in my class, or should I ask everybody? Up to you. Number 18. Calculate the probability of the event for number 19. How likely is it that we're going to get, let me see, green? So they have this spinner, and it's broken into, looks like half the time they're going to be orange, and then we have 1, 2, and 3 down here. So this is broken into, let's see, looks like sixths to me. So 3/6 is orange, which is the same thing as a half. So what is the probability of green? I want a fraction. What is that fraction? Out of 6, how many times do we hit green? And is it likely? Not very likely, or like very likely, or maybe about half the time. How likely is it that we're going to hit green? Number 20, the area of a floor in Ivy's room is 137, so area is 137.5 square feet. If the width of this rectangle is 11 feet, what is the length? Okay, so just like we solved on number 16, you're going to need to do that for number 20 using 137.5 and 11.